Today's lesson is sequence and series, sigma notation. Okay. My learning objective is I will represent a sequence of numbers using summation notation. All right, so let's start out with just reviewing arithmetic sequence. A sub n is the first term. M is the number of terms. D is the common difference. I can take any term and subtract the previous term to get my common difference. A sub n is the nth term. So to find any term, I take the first term plus the common difference times n minus 1. To find the sum of my series, I'm going to take the number of terms divided by 2 and add the first term and the last term. For a geometric sequence, a sub n is still the first term, n is still the number of terms, r is the common ratio, and I just need to take a term and divide it by the previous term, and I'll get the common ratio. A sub n is the nth term. My nth term is the first term times the common ratio raised to the power n minus 1. And my sum of my series is going to be the first term and 1 minus r to the nth over 1 minus r. And r cannot equal 1. Okay, so let's do some examples. So when terms of a sequence are added together, the resulting expression is called a series. A series can be written in an abbreviated form by using the Greek letter sigma, called the summation sign. I is the index of summation. N is the upper limit. And 1 is the lower limit in this example. So my whole series, if I expand them out, looks like the first term plus the second term plus the third term. Okay, so how do I write this in expanded form? So I know I am going from 1 to 10, so I know I have 10 terms. So it's just substituting in, I'm going to say 3, and I'm going to start with k equals 1. 3 times 1 plus 1 plus 3 times 2 plus 1 plus 3 times 3 plus 1. And I'm going all the way out to 3 times 10 plus 1. Okay, so if 3 times 1 is 3 plus 1 is 4. 3 times 2 is 6 plus 1 is 7. Okay, so this is going to be, I'm adding these up. So if I'm expanding it out, it looks like this. Hey, can you pause the video and try the next one? Okay, I know I have 3 terms because I'm just doing 3, 4, and 5. So this is going to look like 1 plus 3 squared plus 1 plus 4 squared plus 1 plus 5 squared. 3 squared is 9 plus 1 is 10. 16 plus 1 is 17. 25 plus 1 is 26. Here's my expanded form. So it's asking for the expanded form. Okay, so I want to find the sum of this. So I have from 1 to 6, so I know I have 6 terms. So 4 times 1 is 5. I'm sorry, 4 times 1 is 4 plus 1 is 5. 4 times 2 is 8 plus 1 is 9. 4 times 3 is 12 plus 1 is 13. And I can keep going. I got 17 plus 21 plus 25. So when I add these all up, the sum is 90. So answer the question. Okay, this one was asking for what's the sum. So I expanded it out so I could find the sum. I know I could also add the first use the this is separate from the summation. So the previous one I could have also used this formula. The sum is n divided by 2 times the quantity of the first term and the last term. So that'd be one other way of doing it. So sometimes I have more than one way. Oops. Uh-oh, what's going on here? All right, so the goal of this is I want to take my series of numbers and write them in summation notation. So that's what we're going to do now. Okay, so I'm looking at, I see that this is my first term, my second term, my third term, and this is my nth term. So from here to here, I have plus 5. From here to here, I have plus 5. So I know my common difference is 5. So I know my nth term is my first term 5 plus my common difference of 5 times n minus 1, and I know my nth term is 250. Okay, so this is really, I'm going to distribute this 5 on these two terms. So I have 5 plus 5n minus 5 equals 250. So I'm going to combine like terms. 5 minus 5 is 0. So I have 5n equals 250. So I'm going to divide both sides by 5, and I get n equals 50. So I have 50 terms. So writing this in summation notation, I'm going to start out with n equals 1, and I have 50 terms. And I'm starting at 1 because I can write this is really just 5 times n. And I just have to write a few of these and try it. So if I substitute these in, do I get these numbers? So these are really the multiples of 5. So the way I can write multiples of 5 in summation notation is 5 times n. All right, so let's try another one. Let's do some fractions here. Okay, so I need to, again, here's my first term. Here's my last term. So I want to find my common ratio, so I can take any term and divide it by the previous term. All right, so I'm going to pick R is, and I'm going to pick the second term and divide it by the first term. So this is 1 over 5 to the 4th divided by 1 over 5 cubed. So I'm going to flip and multiply. So this is 1 over 5 to the 4th. And this is going to be 5 cubed over 1. So when I simplify, I'm left with is 1 over 5. So my common ratio is 1 over 5. So how many terms do I have? I know I'm going from 3 to 15. So 15 minus 3 is 12, but I have one number on each side. So I have a total of 13 terms. Okay, so I'm going to write this. So I'm looking at, it's really kind of 1 over 5, right? But instead of starting at 5 at the first power, I'm starting at 3. So I'm going to say n plus 2, because I'm not starting at 1/5. I'm starting at 1 over 5 to the power 3. So I'm going to say n equals 1 to 13. Okay. So my common ratio is going to be in the summation rotation, but I might have to make adjustments if I'm not starting at 1. And my common difference is in my summation notation. Okay, so let's start out with the next one. Let's look at something else a little bit different. Okay, so I'm looking at these numbers, and I'm really looking at this as 10 to the first power, 10 squared, 10 cubed, and 10 to the 4th. Okay, so I can see my common ratio. If I'm looking at it, I should be able to see I'm really multiplying by 1 over 10. If I need to, I could say my second term divided by my first term. I could do the math and still get 1 over 10, but I can see I'm just multiplying by 1 over 10. Okay, so how many terms? I have 1, 2, 3, 4 terms. So I'm going to set this up from n equals 1 to 4. And this is 3 over 10 to the nth power. So I need to make sure I'm including the 3 because that's in there, but I'm not multiplying by extra 3, just the over 10. All right, so let's try a couple more things I want to show you. Oops. So this time I have some negative numbers. Oops, I'm covering it up. I didn't know I'd cover it up. But my second term and my fourth term are negative instead of positive. So my even terms are negative. So to alternate where my even terms are negative, so I'm going from 1 to 4 because I have 4 terms. This is the previous example, so I'm still going to do 10. So what I still have is this 3 divided by 10 to the nth, but to alternate every other, I'm going to take negative 1 to the n plus 1 power. So I can alternate even and odd and even and odd. And then let's take a look at if instead I have my odd if I have my odd terms, oops, my odd terms are negative, then I am going to, then I am going to, what's the deal here? So n equals 1 to 4 again, but this time I'm just going to raise -1 to the n power. Okay, so I have to take into account a couple things going on here. Okay, so here are the summation of those. Okay, that's it.